So, to continue with our program, the next session will be divided in two parts. In the first, Marco Ruiz will moderate a discussion about the science of climate change. And in the second, we will discuss the politics and economics of this timely and critical issue. Marco Ruiz has been a long-time friend and supporter of FLAR and our conference. Marco is a senior financial officer at the World Bank, where he works as an engagement manager for the Reserves Advisory and Management Partnership. Prior to that, he had a long and distinguished career at Colombia Central Bank, where his last post was as head of international investments. Marco, it's always a pleasure to have you with us. Many thanks once more, and you have the stage to yourself.
Thank you very much, Iker. So it is a pleasure to be here, of course, for a second year in a virtual format. So I really appreciate to be here. So this session is about climate change. So we'll discuss the three parts. So first, we'll discuss the science, then the politics and the economics. So we have, and probably as most of you would agree that climate change is the biggest challenge that humanity has ever faced. So with that, it's really important to think and bring people who can actually contribute to the discussion. So we have the honor of having today two distinguished speakers that will join the event. So first, it's actually an honor to introduce Kate Marvel. Kate is a climate scientist. So she's an expert on science. She works with NASA and she works with Columbia University. But I think personally, what I appreciate the most is that besides being a scientist, she's a great communicator. So really, she is into writing and communicating to the larger public what climate change is and the implications that it has. And then we'll have the chance to discuss Iker, Alex Bernhardt, who's the head of global sustainable investment at BNP Paribas. We'll have the chance to discuss the economics and the politics of climate change, of course, knowing and understanding how complex it is. So with that, I'll leave you with Kate, who will deliver a short presentation, and probably we'll have some time for a discussion later on. So Kate, the floor is yours.
Hello, thank you so much for that very kind introduction. I'm really happy to be here. I am going to try to share my slides. Give me just a sec. All right. So I am super happy to be here, but it's very daunting. It's impossible to cover the entire very exciting field of climate science in just a few short minutes. But today what I want to do is give you an overview of what the science says and why it matters. So first, let's start with a very basic question. What's causing climate change? The short answer is humans. The long answer is also humans. We know that natural factors like changes in the Earth's orbit or solar fluctuations or large volcanic eruptions can and have changed the climate. But human activities, specifically our emissions of carbon dioxide and other greenhouse gases, are responsible for all of the observed warming trend we've seen since the Industrial Revolution. In fact, they're responsible for more than all of it, because actually we think the Earth would be cooling a little bit were it not for human activities. So humans are changing the climate. But who cares? What does it mean? Because nobody actually experiences the global mean temperature. And on cold days, like in a New York winter, a couple degrees of warming actually sounds like kind of a good thing. So why is this such a cause for concern? Now, when I think about the connections between climate and extreme weather, I think actually about athletes doping or using banned substances. When we find out an athlete was doping, do we then go back and say, well, I think had he not been using those substances, he would have come 17th in that race and second in that race, and he would have won that race? No, that's not what we do. We know what doping does, so we take action accordingly. And with climate change, we are arguably doping the weather. We are loading the dice. We are increasing the odds and the severity of certain very, very severe weather events. Now, we have very, very solid evidence for some extreme events and how they change under global warming. The first attribution study for a single event was done all the way back in 2003, and it concerned the European heat wave, which killed tens of thousands of people across Western Europe. Now, we have a very robust scientific link between rising average or mean temperatures and heat extremes. We know that climate change, global warming, is making heat waves more frequent and more severe. But we also know, we have very, very solid physical reasons to expect that warm air holds more water vapor. Specifically, the saturation vapor pressure of air increases at about 7% per degree Celsius of warming. Now, what that means is that when it rains, it pours. There is more water vapor in the atmosphere that can be dumped on us in heavy downpours. This is something that we here in New York City got a real taste of on September 1st of this year, when the remnants of Hurricane Ida caused flooding all throughout our city. We also understand current sea level rise trends very well. We know that if you make water warm, it expands. Warm things expand, and we call this thermosteric sea level rise. We also see halosteric sea level rise, which is fresh water is less dense than salt water. And we also know that water that used to be locked up in ice on the land, whether in land ice or mountain glaciers, is now melting and is running into the ocean. So all of those things together combine to mean that the sea level is not just rising, but that rise is accelerating. And finally, we're pretty sure of certain links between a warming planet and hurricanes. We don't necessarily think that the absolute number of hurricanes is going to increase, but we are pretty sure that the number of those hurricanes, which are very strong, category 4 or 5 hurricanes, is increasing. And that's because warm water is hurricane food. Warmer sea surface temperatures feed those stronger tropical cyclones. We also know because warm air holds more water vapor, they can dump more rainfall on us when they do come inland. And we also know that with rising seas, that storm surge can penetrate farther inland. So these are all examples of extreme events whose connections to global warming are more or less well understood. Now, there are extreme events that are more complex. Fires obviously depend on ignition, which depends on who lives there, what crops they're growing, what the policy is. It depends on suppression, both the policy and how effective that policy is. We know that global burned area is decreasing, mostly because savanna is becoming cropland. But in the western US, there's a very strong signal that fires are increasing. And this is because we know that as the earth warms up, we get more what we call fire weather, more of this hot, dry, dangerous conditions. We also suspect a link between climate change and droughts. Now, droughts are very complex. The definition of drought is very complex. You can have meteorological droughts, which is just when you don't get very much rain. You can have hydrological droughts, which is when runoff is decreased and you're not recharging your reservoirs. You can have hydrological drought or agricultural drought, which means your soil moisture is dry, and that has implications for crop yields. So droughts are very complex things, but we do know that warm air is thirstier air. That increased vapor, that increased water vapor in the atmosphere has to come from somewhere. And that is because evaporation is increasing in a warmer world. So warm air is thirstier air, but changing rainfall patterns, increased plant water use efficiency, and increased plant growth could possibly complicate the projections. We know that reduced pole to equator temperature gradients, the poles are warming faster than the equators. We suspect that that may be making the jet stream more unstable, more wobbly, leading to storms in the mid-latitudes and cold snaps. But the evidence for that is not yet conclusive. And finally, we know that while our aerosol emissions globally are decreasing, that particulate matter, gas and dust that we tend to think of as pollution, that's all decreasing. But warm air, temperature inversions, and fires can lead to high particulate matter concentrations and high concentrations of tropospheric ozone. And those can lead to very poor air quality days, which is another example of an increase in extreme events we could see as the Earth gets warmer. Now, I've heard a narrative taking hold that climate change might be worse than climate models have projected. And this is a very complex topic because what does it mean to be worse? And what does it mean to project something? There are a lot of different variables that come out of a climate model. But I think overall the answer is no. Models have done a pretty good job and they project high probabilities of record-shattering extremes in a warming world. Now, climate models, I think, have done a really excellent job at capturing the large-scale trends that we've seen so far. The NASA GISS model, which is where I work, this model from 1988, which you can see here in the projection in the black, it overestimated the warming that we actually observed, which you can see here in blue, but that wasn't due to the physics of the model. It overestimated the warming because it overestimated emissions. If you correct for this, the projection is pretty much spot on. So climate models, by and large, do a very, very excellent job of capturing large-scale trends. And they also do a pretty good job of capturing extremes. In fact, models project record-shattering extremes, like the heat wave that we saw in the Pacific Northwest this summer. Climate models suggest that record temperatures will not necessarily gradually increase as the Earth heats up. Instead, these simulations show sudden changes, abrupt events, which are far, far above previous record levels. So record-shattering events is something that the climate models have led us to expect in a warming world. So finally, how bad is it going to get? And there is a lot of uncertainty in this question, because after all, this is an experiment that we have never done before. And I think when we talk about bad things, it's important to specify what exactly we're talking about to get the terminology straight. So I want to differentiate quickly between three things. First, the runaway greenhouse effect, in which carbon dioxide traps so much heat that the Earth is no longer able to cool itself by radiating to space. Second, positive or destabilizing feedback loops, where warming causes climate change that feedback or increase the warming. And finally, tipping points, dramatic, irreversible changes. So let's start out with the runaway greenhouse effect. Do we think that humans' carbon dioxide emissions could lead to a runaway effect, boiling off the oceans and turning the Earth into Venus? And the answer is no. There's not a lot of evidence in the paleoclimate record to support something like this. However, when we think about positive feedbacks in which warming causes climate changes, which feed back on the warming, we do see evidence that these are already in operation. An example is the ice albedo feedback. You make it warmer, you melt ice. Ice is shiny, it reflects a lot of sunlight to space. As you melt the ice and reveal darker ground or water underneath, that is going to accelerate, speed up the warming. So that is an example of a positive or destabilizing feedback. And that's something that we as scientists understand very well. But there are other feedbacks that we understand a lot less well. For example, cloud changes. So cloud changes are the least well understood climate feedback. And the state-of-the-art climate models, the brand new climate models that are being used to inform some of the projections made by the IPCC, they project very, very large destabilizing cloud feedbacks. And as a result, very high climate sensitivities, very high temperature increases in response to the doubling of atmospheric carbon dioxide. Now, I participated last year in a new expert assessment of various lines of evidence for climate sensitivity. How hot will the Earth get if we double carbon dioxide in the atmosphere? And what we found is that this climate sensitivity to doubled carbon dioxide is likely between 2.6 and 3.9 degrees Celsius. We found that those high values, those climate sensitivities of 4, 5, 6 degrees, kind of nightmarish results projected by some climate models, are pretty unlikely in light of the amassed body of evidence. But the flip side of that coin is true. It's even more true. Low values of climate sensitivity due to some natural stabilizing or negative feedback, some planetary control on the warming, those are even more unlikely. Finally, what about tipping points? Tipping points are potentially dramatic, irreversible within a human lifetime changes that could be triggered as the Earth gets warmer. Some examples of these include disintegration of the Greenland or West Antarctic ice sheets, which would lead to rapid and catastrophic sea level rise and severe coastal flooding. We also could see tipping points in the biosphere, like shifts in the boreal forest or dieback of the Amazon rainforest. These would be catastrophic because forests sequester a lot of carbon dioxide, And by turning the Amazon rainforest from a carbon sink into a carbon source, that would make the warming even worse, put even more carbon dioxide in the atmosphere. We could also see tipping points in physical aspects of the climate system, like a disturbance to the Atlantic meridional overturning circulation, which regulates the climate in the northern latitudes, or shifts in the Indian monsoon or the West African monsoon. Now, the scariest thing for me about tipping points is I can't tell you, no scientist can tell you exactly when these will be triggered. There is no safe level of warming. We don't know exactly how close we are to any of these tipping points. So the more we keep emissions down, the better, the less of a risk we're taking. So finally, does action matter? Are we doomed? Should we just throw up our hands and accept inevitable climate change, possibly triggering these tipping points? And I think the science says very much not. We are not doomed, and action matters incredibly. Now, I talked a lot about uncertainties in the climate in the future, but by far the greatest uncertainty is us. It is what humans will do. It is still possible, as you can see in this green trajectory, to stabilize global temperatures. It's also possible to increase emissions, follow this red trajectory, and see 6 or 7 degrees of warming. I want to put that into context for you. The difference between now and the last ice age is about 5 degrees of warming. So these are huge differences in the future we see. Now, we just lived through an unplanned experiment, climate and COVID. The Earth basically shut down last year. So what did that do to the climate? Well, greenhouse gas emissions dropped about 7% in 2020. But greenhouse gases are long-lived. The climate responds to cumulative emissions. Moreover, aerosol pollution, that gas, dust, particulate matter, blocks sunlight and actually has a planetary cooling effect. So COVID-related reductions in aerosols actually had a slight warming effect on global climate. And as a result, 2020 was the second hottest year on record. In the long term, to stay below 1.5 degrees Celsius, greenhouse gas emissions must fall not just by 7% last year during COVID lockdowns, but by 7% every year. We can see that it would have been easier to keep global temperatures below 1.5 degrees Celsius had we started 20 years ago. The longer we wait, the steeper that curve gets until eventually it becomes impossible. Right now, we're running out of time to limit temperatures to below 1.5 degrees Celsius. That target is still within reach. It's going to be incredibly challenging, incredibly hard. But if we put it off long enough, it will be completely out of reach. So I'd like to summarize, and then I'm happy to take questions, by saying, first, we know exactly what is causing climate change. There's no mystery here. Humans are causing more than 100% of the observed warming trends since the Industrial Revolution. And we know that matters because warming means more extreme weather. Warming means more heat waves, more downpours, heavier downpours. It means more fire weather. It means enhanced droughts in some regions, and it means poor air quality days. Moreover, there is no safe level of warming. We cannot guarantee that even if we limit warming to below 1.5, we won't see triggering of some tipping points. However, every 1/10 of a degree matters. Every bit of warming that we can avoid, every ton of emissions that we can prevent really, really matters. It's not possible to avoid climate change. It is already here. Global average temperatures are already 1.2 degrees Celsius higher than they were before the Industrial Revolution. We are already seeing numerous extreme events that can now be robustly linked, quantitatively linked to climate change. It's not possible to avoid it. And in the near future, some adaptation to a new climate will be necessary. However, it is still very, very possible to avoid the worst case scenario. because the biggest wild card in climate change is what humans are going to do. So thank you very, very much for listening. I really appreciate being here, and I'm happy to take questions.
Excellent, Kate. Thank you very much for that very, let's say, concerning presentation, but at the same time, you managed to be hopeful. So let me ask you one question. So most of the audience actually most people are not experts on climate change. However, what we see a lot in the news is the discussion around 1.2 and 2 degrees Celsius, whether that increase, whether the policies will actually lead us there. The question is, but now that I see your presentation, I'm a bit concerned that may not be enough. That may be actually an overstatement because, so the question is, can we actually expect should be concerned even if we get to 1.5 degrees Celsius?
Yes, I think some adaptation will definitely be necessary. The Earth has not globally been this warm for thousands and thousands of years, arguably, well, definitely never in human history. Now, I think that should be motivation to adopt policies to really focus on climate adaptation as well as mitigation. For me, it's not an either or choice. We really, really need both, because right now we are so sure that so many of the trends we see, and increasingly because of advances in attribution science, we can actually tie specific individual events to climate change. We can say things with confidence, like the Pacific Northwest heat wave that we experienced in the US this year would have been effectively impossible without global warming. So climate change is already here, and everything we can do to make sure it doesn't get worse is going to be very necessary and very valuable. But at the same time, we need to deal with the change that is baked into the system because of choices made in the past.
Thank you. So let me now refer to your TED Talk. I think your TED Talk is very, very popular, and I definitely encourage the audience to look it up. It's definitely worth seeing. So I think one of the issues that you mentioned is, and you discussed the issue regarding climate models, the fact that they are not perfect, but the value is really in the information and the insights they provide. Now, as a climate scientist, what do you think are the biggest challenges of these climate models? What they may possibly be ignoring that we don't know yet and that may have substantial consequences for the planet?
I think that's a great question, and that's something that I think of all the time. When it comes to climate models, I think it's important to understand the different types of uncertainty. So there is fundamental irreducible uncertainty in the climate system. We will never be able to predict the weather 10 years in advance. I cannot tell you what the weather January 10th, 2031 is going to be like, for example. That's just not possible because of the inherent randomness in the climate system. And that's not what climate models are trying to do. Now, there is another sort of uncertainty which deals with the fact that there's still science that we don't know, still questions we have yet to answer. Some outstanding questions include exactly what are clouds going to do? How big is that destabilizing feedback we're going to see as clouds rearrange themselves in a warmer world? That's an example of a question that is an uncertainty in climate models, but is something where we can narrow the bounds of that uncertainty by doing more science, by finding more things out. Finally, there are things, what I would call unknown unknowns. Things that could happen that are left out of climate models, things we haven't even thought to think of. And that obviously is really difficult to speculate on, because if we knew about them, they wouldn't be unknown unknowns. But I think as climate models have gotten more and more sophisticated, we've included more and more processes in the Earth system. So we started out with models that just modeled the atmosphere. And then we realized that the atmosphere and the ocean are very fundamentally linked together. So we have climate models that include the ocean. And now we have climate models that include the Earth's surface, because we want to look at carbon cycle feedbacks. What's going to happen to forests, potential sinks of carbon as the atmosphere heats up? So as climate models get more and more complex, they include more and more and more stuff, meaning that the number of things that could be unknown unknowns is shrinking. But I think the message is always going to be the same. It's always going to be that the risks are lower, especially those tail risks. Those really, really shrink as we limit emissions.
So thank you. So let me ask you, another thing. Probably you mentioned in your blog that despite being a climate scientist, you enjoy the privileges of modern life, and we all do. So so there's also, and we all love driving, and probably we all love like connecting this way, but unfortunately that is creating significant impact on the planet. So the question is, some people are discussing how to actually have a sort of a free lunch in terms of using technology to create, for example, carbon capture technologies or geoengineering to solve some of the issues without really cutting fossil fuels. Do you see that as something feasible or even desirable?
I think we will need carbon dioxide removal. All of the scenarios that I've seen that keep us to below 1.5 degrees incorporate technologies that pull carbon dioxide out of the atmosphere. Those are not a substitute for mitigation. We need to see really rapid emissions cuts at the same time that we see carbon dioxide removal. So they're not a substitute. They are a necessary accompaniment. There are different ways to do this. Reforestation forests, and the ocean, phytoplankton in the ocean, seaweed in the ocean, whales in the ocean are incredible sinks of carbon. They've done an incredible job at they take up about 1/3 of the carbon dioxide emissions that humans have put in the atmosphere. So maintaining those, preserving those, enhancing those, I think is fairly uncontroversial. There are other methods like bioenergy with carbon capture and storage, direct air capture of carbon dioxide, or carbon capture and storage at the source that are also, in their infancy, possibly technologically feasible, but whether or not they're economically feasible, I think is something to be determined. But the takeaway, I think, is that carbon dioxide removal is good and necessary. It cannot be a substitute for emissions reductions.
Excellent. Let me ask you one final question. This is actually related to communication. So you spend a lot of the time not only doing climate science, but also talking to people and even social media. And you have seen also a lot of pushback. You mentioned there is a lot of pushback to some of your ideas. So what do you think is driving this pushback to climate change? Because at the end of the day, we want to solve the climate change problem. We really need everybody to have everybody on board. So how do you feel, and from having this communication role, how do you feel that, or what do you think is driving this skepticism regarding climate change?
The nature of the pushback has changed incredibly over the past 5 years, which has really surprised me. Initially, it was a lot of science denial, a lot of, the sort of manufactured doubt. Are we really sure? Is there really a consensus? Yes, we're really sure. Yes, there is a consensus. And now I think it's really changed. A lot of the pushback now is on specific policies. Is this a good idea or not? And that's something that I actually welcome, because I think we need to have a robust debate about how good various policies are. But I've also started to get pushback on, it doesn't matter. Emissions cuts don't matter because we're all doomed, or people will never give up their comfort, or whatever. And that, I think, is a new thing for me, a new thing that I experience. But it's rooted in the same kind of narratives of delay and denial. I will say that we know we get plenty of energy from the sun. All energy is fundamentally solar energy. Wind energy is solar energy because the sun heats different places and that pushes air around. And we know that fossil fuels are fundamentally solar energy. It's solar energy that was captured and used for photosynthesis millions of years ago. So we have no lack of energy. We have no lack of human creativity. And increasingly, I think we have no lack of popular will. I think the public is increasingly behind climate solutions. There are vestiges of vested interests who are blocking progress. And I think that too will fall in the future. So I am optimistic, but again, we have to make our own optimism, I think.
Thank you very much, Kate. So with that, I'm really grateful for your time. I imagine you're very busy, but we know that your message will be really impactful in our region in Latin America. So thank you very much for all your time.
Thank you.
So Iker, over to you.
Yeah, so thank you so much, Kate. We do hope that your message will help in raising the general consciousness of a region, Latin America, and bringing about a positive change in Latin America and the world. So many thanks once again. And with that, we will proceed to the second segment of our session. As previously stated, we will discuss the politics and economics of climate change. In this segment, I'll be speaking with Marco and Alex Bernhardt. Alex is, as Marco mentioned, the BNP Asset Management Global Head of Sustainability Research. So thank you, gentlemen, for accompanying us and making this event possible. And with that, Marco, I wanted to maybe make a small debrief of your session with Kate. You did mention some things that did strike you as interesting or new information and so on. But in general, what are your thoughts after your conversation with Kate?
I think, what I liked about Kate's session is the simplicity of the message and how powerful it is. So first of all, the fact that it's, the very simple link between human activity, carbon emissions, and global warming. So basically what she says is there is a scientific consensus on that link. And the concept, and of course, she raised a lot of issues in terms of climate change is really concerning. Not only because of what's going on right now, but what could happen in the future. However, she offers a hopeful message in the sense that we can still do something. So not everything is lost. We can still do something to decrease emissions and then affect further damage to the planet. So from that, I think it's a very powerful message. I think she manages to convey that message in a relatively hopeful way, which I think it's really encouraging. But I think that's the most important takeaway of her session.
Yeah, I agree. Another thing that I found important and in the hopeful message that you do, it's on the one hand, she says, well, it is a fact. It's not whether it's getting warmer or not. She says that more than 100% of the warming since the beginning of the Industrial Revolution is due to human activity. But then she goes about that it is still preventable. So it's not like we are doomed. Things can be changed and it's still at hand, but we do have to get moving. But one thing that I do find a bit concerning is this concept of the tipping points, that at some point, it is just impossible to model what will change the dynamics at what point in time and how. But after that, irreversible trends may just come to take place. So I do agree with you. It was, on the one hand, very sobering. This is a fact, but on the other, there is hope. But we do have to get our act together. So maybe with that, we can begin this segment of the conversation. A very important backdrop to this conversation today is that the Glasgow conference on COP26, taking place this week and the next one, and world leaders and experts are talking about these kind of things. And in that context, one reflection that we had in our previous conversation is that I do think it can be hopeful that, if the world sees an imminent threat, like it was the case of COVID, the pandemic, it was a clear and imminent existential threat for humanity, and the whole planet stopped and took care of that, and it's not over yet, but the existential threat has been taken care of. So humanity can act and can do what's necessary. But what Kate describes is more, I mean, it's a slow-moving threat. I mean, it's definitely a deadly one, but it's a slow-moving threat. It's not like an asteroid is coming, and then we have to get together at that respect. So humanity is not reacting to this existential threat in the same way that it reacted to COVID. So maybe I wanted to ask you, either one, on this conference in Glasgow that is taking place with this information that Kate shared about the problem itself. What is it that either one of you guys may how do you view the dynamics at Glasgow? What could we expect or not to happen as a result, and will it be enough or not?
I'm happy to start that one off, Marco, and maybe we can go back and forth a bit. But COP26, as you said, is ongoing, and there have been some announcements even in the last 2 days of interesting and very important agreements on methane emissions and on deforestation, which is all very positive progress in the right direction. I think there is some optimism around what we might be able to achieve collectively. The policymakers representing our interests, rather, at COP26 might be able to achieve collectively going into this COP, which is probably the most significant COP to take place since the Paris Agreement was ratified. Given that there's a 5-year sort of stock taking place now. There's been some headwinds. However, the U.S. has yet to pass a significant spending package with significant climate spending associated with it, and there's some challenges to getting that through. A lot hinges upon what China determines to do, and they've made some strong commitments as well, but continue to build coal power. So there's a lot at stake here, and a lot that needs to be determined still. And going into this event too, the collective commitments from countries through their nationally determined contributions were still tracking well above 2 degrees in warming. And so we have a lot more progress to make, and our policymakers need to show more ambition in order to really address this problem in the way that it needs to be addressed to get to net zero emissions by 2050, which keeps us to 1.5 degrees in warming, which is the best case outcome that we can hope for at this point. I think that there's, and if you don't mind, Iker, I'll just pivot here a little bit and talk about the investor role in this whole thing. There's a lot of emphasis on what policymakers should do and can do, and rightly so. I think that policymaker action is absolutely necessary to achieve the transition to a low carbon economy that we need. However, I don't think that it's sufficient. This is a full economy transition that needs to take place, and investors are a key actor in the overall system, the global economic system, that need to also send a signal to policymakers that their action is needed. And additionally, we have the ability as owners of corporations, either their equity or their debt, to influence corporate action as well. And so all of these things are interconnected. What corporations say and what investors say influences policymakers. And therefore, sitting on the sidelines and waiting for policymakers to act, I don't think is a reasonable proposition for investors on this very systemically important issue, one that causes risks to financial stability and the long-term returns of our portfolios over a long enough horizon. So anyway, that's something that I'm often confronted with in conversations is a sense of apathy or lack of ability to do anything. But every action really counts, and I think the same is true in the investor space as it is everywhere else.
Yeah, those are some very interesting and important points. Maybe we can come back to that in a minute or so. And Marco, how about you on Glasgow? What are your thoughts, expectations, general mood, and so on?
Sure. So let me probably take a step back and probably look at the bigger picture. I think from Kate's discussion, it's also the issue, I mean, basically it's clear what we have to do. We have to reduce carbon emissions. That's clear. And hopefully completely. The challenge with that is that basically the whole economy, world economy and everything related to the way we live will have to change in a way, right? Because we depend on energy. So the question is, how do we change from fossil fuels to other sources of energy? I think there are two issues in general that we're trying to solve. So one issue is that we have to do it collectively. So I mean, it doesn't matter if probably just, I don't know, half of countries decide to move that way and the others do not. So we really need a collective effort to get there. And the second one is, and it's the significant question is who pays for it? Because all of us will have to pay for it in one way or another, right? So we know that we're talking about a dramatic change in the way we live, in the way we work. So the question is who will pay for that? That's actually what I would expect COP26 to actually make progress on. So I think as a humanity, basically we haven't been able to achieve any of those goals so far, either creating collective solutions and collective agreements or actually determining who will pay for that cost. So COP26, I mean, if it's successful, we will get a little bit closer to that goal. The problem, of course, is that we know that definitely, unfortunately, it will not be easy to move as fast as we want. Just because, again, we need the two things. We need collective responses. So we know that, unfortunately, some of the countries are having issues, either because they have political issues. Some countries actually are facing the issue of facing their voters, right? So no politician in their right mind can actually, I mean, feels like I want to hurt my voters in the short term so that we can actually save the planet in the long term. That's a very difficult decision, and we've seen it. I think we saw it in France a couple of years ago with the Gilets jaunes. The fact that you're actually increasing oil price can cause all sorts of reactions. And so that's one significant issue. It's not only the economic, but also the political issues. So some countries are having issues dealing with any of those. So that's definitely on the collective. And on the cost, it's clear that, fortunately or unfortunately, the rich countries will have to bear most of the burden of the financial economic burden because they are the ones who have created the most emissions. Now the question is, definitely there has to be some compensation from rich countries to poor countries. But unfortunately, so far, that compensation has not been as strong or as effective as it should be. So I would expect COP26 to make a little bit of progress there, but definitely COP26 will not be the end solution. It has to be a continuous progress where we keep on meeting and try to, again, fighting. And as a human race, as you said before, we have to find the solutions to the most complicated challenge we have ever faced as humanity.
Yeah, well, what you mentioned is a crucial element of the dynamic. And maybe, Marco, I know that you have thoughts on this subject. And going back to the comment that Alex brought to the discussion on the role of the investors, what we see, it's on the perhaps the United Nations political side, policymakers and the like, not necessary. Not all the necessary action and commitment taking place. And then there is some sort of like a chicken and egg element. So Kate did mention this is, something that we have to get going immediately and aggressive, but the actions are certainly not following suit. And then one interesting thing that Alex brings to the equation, I think it helps to sort of answer or at least get moving the chicken and egg question. So how can the planet get moving? And then Alex says, okay, investors can play that role. I do find, that as a powerful proposition. If enough investors that do have the money and can direct it to initiatives that find maybe beneficial or not, then that can also influence policymakers and society and so on, and create a positive feedback loop. But I do know you have thoughts about that respect.
Absolutely. So, but I think there is definitely a role for investors to play. But I would say I'm a bit more skeptical about the role in terms of signaling. For example, in terms of avoiding investments in certain companies because they are creating too many emissions. I think that and possibly increasing the cost of capital. Might that work? Yes. Might that be a game changer? Probably, in my view, not. I mean, just if you look at the challenge that we're facing, I mean, when you look at the estimates, there are some estimates that actually the money that has to be spent or invested, is around $131 trillion in the next, basically by 2050. So we're talking about a major resource investment. So we need to actually find a way for portfolios to facilitate that transition, to finance that transition. So only signaling may not actually get those 131 trillion. But if we think about how we find a way to, from the portfolios to actually get away, right, from carbon emissions and eventually financing fossil fuel production. And we find a way to actually finance renewable energies and this climate transition, that can make a significant change. So just to give an example, we're talking about 131 trillion. When we focus, for example, in a lot of the people in the audience, global international reserves, we're talking about 14 trillion. So it's only a fraction. It's about 10% of the needs. But if we find a way, for example, to actually move those resources let's use those resources to finance that climate energy transition or that energy transition, that's actually the role, and that's actually how investors can think about it. And we need to think about how that we can facilitate that. So I think we have to go beyond creating signaling, either positive of signaling or negative signaling. In my view, that's not enough. I mean, the size of the challenge is such that as investors, definitely we have to be more proactive.
Can I jump in there, Rico?
Yeah, I was about to invite you in. I know you have thoughts on that, so please go ahead, Alex.
Okay, yeah, right on. So I totally agree with you, Marco. I think signaling is also not enough, but it doesn't mean that it shouldn't occur. And actually, to the contrary, I think we need more signals, in part because I think it can influence policymaker action as well as corporate action, and those are two of the most important segments of the economic system that need to act to move towards net zero. But yeah, I also agree with you on the capital allocation point. So if I zoom out a bit, I mean, I think investors have broadly two different tools that they have at their disposal. They have capital allocation, and then they have engagement or the ability, or stewardship, as it's sometimes called in other markets, which is the ability to vote proxies in equity or to actually have an active audience with the issuers that they invest in. And on the capital allocation side, divestment has been a big focus of the sustainable investment field for many years. The impact of that activity on the cost of capital of divested companies has been shown through academic research to be not terribly strong. The more important impact is perhaps signaling or stigmatization of companies, which may increase their cost of capital, say on debt markets. Yes, I think that needs to be a part of the equation, divestment or reduction of the investment universe to avoid the worst offenders is a potential strategy, but it isn't as effective as when it's coupled with engagement, and encouraging companies that have not yet adopted net zero strategies to adopt net zero strategies, or encouraging companies that are in high emissions intensive industries to think differently about their business model and business strategy over the long term, and then to use those two levers in parallel as a carrot and or as a stick to encourage the action that we need to see in order to manage the systemic or beta/market risk that climate change poses for all of our portfolios. And so I think that's really important. And just as an example, I mean, some of the things that we're doing at BNP Paribas Asset Management, we've been filing some shareholder resolutions with some major corporations, asking them to, as a sort of starting point, to disclose what they're spending on lobbying. And we've had shareholder majority votes on three major proposals of three major U.S. corporations last year, to compel them to disclose that information, which is a starting point. It's a step in the right direction. Recognize it's not a panacea, but it's what we can certainly do from our perch here in the investment segment, and we hope to see more of that kind of activity from us and from our peers going forward.
Yeah. Well, thanks. And that's that has probably a lot to do with this perspective of developed markets and so on. But I know, Marco, you have also thoughts on the developing side of the equation. Things that may work in developed markets may not work in the same way, or other things that are not effective in developed maybe are more effective in developing. So if you could share your thoughts on that.
Yeah, absolutely, Iker. So, I mean, for example, I think one of the issues that is being discussed as in terms of let's say, including sustainability objectives in portfolios is, for example, excluding certain sectors, right? So, for example, avoiding that your portfolio finances, for example, fossil fuel production. But then at the same time, you have issues, and the example probably, I think it's a good example. There are a lot of countries are actually low income or lower middle income countries that have recently discovered oil, and they realized, or they thought that oil would be the path to actually achieving middle income status or eventually upper income status. Unfortunately, now we have to tell them, no, I'm sorry, you cannot do that. And that has significant social implications in terms of poverty reduction. So, I mean, if you think about these strategies where you actually say, okay, I'm not financing, for example, projects in a particular country, not because of you or who you are, basically, but because we're trying to get away from fossil fuel production. You also have to think about the potential consequences of that. So if you actually stop funding a particular, for example, country in that way, you really have to be aware of the consequences that you may be making things worse. And even at the extreme, you may have actually political reactions either in that country or even in developed countries themselves, right? If you see this. So this is, I mean, you have to tread very carefully in terms of the impact. I think one significant, at least from the World Bank, something that the World Bank is actually promoting is actually helping countries still achieve and development objectives. So that's and then we need compensation. Despite achieving or not achieving or certain reductions or avoiding increasing emissions in certain areas, for example, fossil fuel production, at the same time helping these countries develop and achieving better, I mean, reducing poverty and achieving better sustainability. So I think it's, as investors, we have to think about how we design these mechanisms and avoid these second round effects and these unintended consequences of certain simple policy that seems simple in practice.
Yeah, maybe, I mean, we only have like 5 minutes, but I wanted to dig a bit deeper on some of the elements that you mentioned, Alex, and on what I mentioned also, opening this segment and on creating a positive feedback loop. So investors can have an important role in getting the ball moving and getting traction, but then a way for that not only be an altruistic element, but to do well by doing good. What kind of incentive, be it tax or other things that should policy makers be thinking about in order to bring some reinforcing elements to incentivizing the investors to not only do it because of their heart, if an investor can one can say has that, but to put a premium on this good behavior.
It's a great question. I mean, there are a number of different things that I think need to take place in order for us to, from a regulatory or policymaker standpoint, in order for us to be able to achieve the end goal. I mean, what the table stakes from the financial services perspective really is around disclosure, making sure that we have adequate information from the companies and other issuers that we're investing in to make sure that we're assessing the climate risks that those issuers face, and or in the sense of this new emerging concept of double materiality, are able to assess the impacts that company or issuer is having on climate change. And those are increasingly easier to assess now that more and more information is coming to market. But most of that disclosed information remains voluntary. We have regulation coming into force pretty much actively as we speak in Europe, which is going to be pioneering in many ways. It's going to push a lot of the financial services industry and companies that are wanting to be active in capital markets to disclose more information. And so that's going to be a great starting point to improve and enhance the pricing of climate risk in the marketplace. I think that, in touching back on Marco's earlier point about the importance of investing in solutions and providing the capital flows that are needed, they're going to be super significant to achieve the transition and to invest in the renewable technologies and that we know exist and that work, and the new technologies that haven't even been invented yet. Trillions of dollars of capital needs to be channeled in that direction. And, one of the things that we've noted in our research is that, allocations to emerging markets, for instance, are underweight in many portfolios. And it's in emerging markets where a very large lion's share of the investment is needed. And so that needs to be corrected over time, and then those investments need to be greened or rendered sustainable. And one of the challenges, as Marco said, is that there are unintended consequences of investing, or halting the investment in say fossil fuel-based industries in emerging markets. And so we definitely need to manage around that. But one of the ways to do that could be through the use of creative financing techniques like blended finance, which many of the development finance institutions are already pioneering. But we definitely need to scale that kind of thing up significantly to make sure that investors are comfortable with the risks they're taking and understand that the transition is being supported, not just by their actions, but by policymakers as well. And I could go on, but we're running out of time, so I'll stop there.
Yeah. On that note, we only have about a minute, but I did want to get a bit of Marco's perspective in a minute. I'm sorry. On what is it that you're seeing on your place, and what is it that you are trying to accomplish, and how do you see this playing out?
Okay, so what we're seeing is gradually more interest in incorporating sustainability into investment management in official institutions. So what I think, and probably just following up on what Alex mentioned, the issue, of course, is how to do it and how to do it in a reasonable way. So what a lot of institutions are doing is actually investing in green bonds, for example. That's a way. However, I think it's definitely far from enough. I think the concept that in and out of itself, it's actually very, very important, the way that you're creating a mechanism for portfolios to be invested and to be financing renewable energies, for example, or the energy transition. The question is, how do you make it larger? And I think that's the important thing. So definitely it's not enough. Right now it's very small. So hopefully if governments start using a similar, it doesn't have to be green bonds, but a similar mechanism to channel portfolio investment into renewable energy and the energy transition, that would be essential both for portfolio managers, but also for climate change.
Well, many thanks to you guys. Apologies for the time, but I realized that it was really ambitious of us to try to cover not only the science, but the politics and economics and investment sides of climate change. So really, really appreciate you being with us. This has been a fantastic session. I absolutely loved it and wish I had more time. Thank you for sharing your expertise and perspectives with us and the audience. Hopefully the tide will change and we'll be able to bring a more sustainable planet to our children. And with that brings us to the end of the day one of our 4-day conference. We are extremely grateful to you, our audience, for deciding to join us and making time in your extremely busy agendas. Thank you so much once again. We'll resume the conference this coming Thursday at 11 a.m. Eastern Time, and we'll be tackling a couple of very disruptive and transformational issues for the coming decade. First, we'll talk to Campbell Harvey about his new book, DeFi, or Decentralized Finance, and then we will be discussing the future of work with Robert Posen and his book, Remote Inc. So until then, stay safe and we'll be seeing you. Thank you so much.